Welcome back. Thank you for joining me for this video. In this video, we're going to get the model of a toothpick holder that we made in the last video to be ready for 3D printing in this video. So if you haven't seen us make the toothpick holder in Fusion 360, please watch the last video. The link will be in the description. So here we have a program open called Cura. This is a free software. A lot of people use it and it works well. So if you have Fusion 360 and Cura at home, you can make this project pretty easily at home just by watching the video. It is not something that is difficult, and I think that it'd be a very good thing to try, especially if you're interested in design at all or 3D printing and you want to learn how to make your own things instead of using Thingiverse all the time. So in order to get your file ready to be printed, you're going to have to open it in your slicer. So you can click and drag it into it, or you could go under File, Open Files, and pick your file. So right here in yellow, we have our model. And most 3D printers won't be able to print this unless they're using some sort of sorcery. So ours probably won't be. So we need to orient this print in the best possible way to 3D print. And we could do it on this face here. It's flat. You like flat faces for your 3D prints on the bottom, but eventually that would be an issue. You could use support material, but if you print it where this is the bottom, it would print very easily. So if you click on your model, you get these options here, and if you don't, you can click it first and then click your model. Right here we have the rotate tool command open. You can press R. They just added these hotkeys recently, which is convenient, but if you don't know them, you can click that and then on your model. And these rings here obviously dictate which way we're spinning the model. And we want this bottom part to turn this way. So we take the red ring and we move it this way. And if you play around with this and you get a little off, it will be very difficult to get it in the right orientation after that. And when I was first starting out, I noticed that for some models more complex than this, it's very easy to get yourself confused. And then when you think you have it perfectly lined up, it's not really, and you'll have something where the model will be touching the bed only in one spot, and then the rest of it will be above it. And sometimes it's very hard to tell. So Cura has made this really easy to make sure that you're on the bed. You take this here, which is under rotate, and you press lay flat. And it will calculate and figure it out. And very easily, you have your model laying flat. And that is just a really good thought that they had. So what you'll want to do is make sure that you have it in the orientation that you want. And I think that's good. So right now we're in solid view. And solid view really shows you what, if a printer was not going to mess up at all and it was printing really well, what it would basically look like. However, that's not really how 3D printers work. They're not injection molders. So this is kind of more realistic to what it would be like. The colors wouldn't be there. But you get these lines here, which are accurate to what the printer will attempt to do. So these lines are dictated by our settings that we have here. So I like to go from it top to bottom. I don't use everything, but we can start off with quality. Quality is looking, when you're talking about quality, you're talking about each line. You're dedicating information and dimension to each individual layer, and that line that forms that layer. Right here we have a layer height of 0.2 millimeters. And what that means is that every single layer is 0.2 millimeters high in the Z direction. We have 300 layers of 0.2 millimeter height. And if you go down here, it gives you an approximate time of 1 hour and 22 minutes. It's not immensely accurate, but it gives you a good sense of how long this is going to take to print. So if we change this to 0.1, it might be difficult to tell, especially if it's not loading. But once it's loaded, you'll be able to tell that these lines are way smaller. They're literally half as big. And that would give you a really nice print. It would look really good, but it's going to take almost 3 hours now, and it realistically probably would take 3 hours. I'm printing on a CR10, and when I mix CR10 and Cura together, the print time's always off. It was off on another printer I had, so I figure it's on the software side, but it's free software, so what are you going to do? And then if you're like, okay, well, if smaller takes more time, then bigger takes less time. Well, that's true. It does take less time. It takes less than 1 hour, according to Cura. However, your lines are definitely bigger, and it does lose some features. If you had some smaller geometry on here, you might lose them. In fact, if you're doing text, you often will lose them if it's not modeled correctly for that layer height. So 0.2 is the best of both worlds. Instead of 56 minutes, you get 1 hour and 22 minutes. And that's reasonable, especially since you don't have to baby your printer. You can just go in the other room, as long as it's safe. You know, you make sure you have smoke detectors, and you, just in case of a fire, it could happen. But that's not going to happen for us. So we have our layer height set, and there are other options here, but don't worry about those for now, especially if you're just starting out. So the next thing that we can worry about is our shells. Our shells are basically, instead of going up and down, we're going left to right. It's our thickness. It's how the structure of the walls are. So we have wall thickness, and we're not going to change that. I can't click on it. That's one of the reasons why we're not going to change it. But we have here wall line count. This is how many walls are in your model. So for most of the print, it has 3, but sometimes it's not big enough to have 3. So it won't put it in there. But when we get down to here, we see that there is 1, 2, 3. And then there's 3 on the other side. So this means that if I was going to cut it in half, it has 3 on both sides. Well, if it's full, it has it on both sides. So this will add strength to your print. It'll make it less flexible. It'll make it more rigid and firm. So if we change this, it'll make it thinner. It'll take less time, and it'll take less material, but you have a less quality, less strong print. And we don't want our prints to break. And here's a pro tip. I use concentric on my layers here. If I did lines, then on the bottom here would be a good example. You see how these lines happen here, which is fine. It'll print. It's not a bad way to do it. But there will be those small gaps you saw. And so, in reality, those might not even show up. But this, to me, as long as you have a printer that can do it, it's better. It's more watertight, more solid print, and it will make you have better prints if you do that. In my opinion, you have concentric here as an option. If your slicer doesn't have that, go get Cura. So that's good for the shell. Now for infill. Infill is the inside of the print. It's filling the inside. It's pretty simple. So here we have how dense the part will be. Now here is where most of your material is, where most of the empty space is. And what you need is a place for this bottom part to start. If that was empty, then it would be printing on thin air. and it really would not work. It's hard to tell, but there is no way without some sort of support that this would happen, because right now that's floating, and that's just, I don't understand how anybody would be able to print that. You'd have infill, but you'd have to have it inside your model, um, or sorcery. That's, I guess, the other way. So instead, you'd use infill. You could do 50%. That would definitely do it. And at 50%, you have something where it can print on. If you don't like that, you can change it to a higher density, and that means that the space between those walls are not as, spacey. It's filled. You can change the shape of it too. You could even do concentric for that. However, I don't usually do that. I usually use the line or the grid pattern for infill, because you get these, and those probably are nice in some way, but I looking at it without any tests, I think the grid would be better. It also uses less material that way, and it prints about the same. Another thing about concentric is that for each line, it has way less distance to travel on one layer. So, in theory, concentric is faster both for infill and shell. For the time constraint, it helps that. However, it's minuscule. Unless most of your print is infill and it's a giant print, I wouldn't really mind just sticking with grid. So, moving on from infill, we have material. This is where you set your temperatures. I'm using PLA, and I'm using a PLA from MakerGeek, which prints at a higher temperature than most PLAs. When I first started out, I think I was using like 200 C. Now I use 240, and it says to print at 235, and I print hotter than that, just because I like that extra adhesion, so my layers form better. So, I mean, these numbers pretty much are trial and error. You got to just figure out what you like the most. Speed, this is how fast the print is. This will depend on your printer. I print at 65 for this stuff. If I was printing something that is very, very detailed, I would slow it down maybe to 50. Cooling is the fan. A lot of people make modifications to their cooling, and they do get results, but I find that there's no difference for me with the fan or without the fan. Either get or I won't get the stringing, and I usually don't get stringing, so I just leave it at 25 to save on energy, and I don't know. Then you have your support, which we don't actually need. A lot of people would look at these holes here and they say, well, it's going to be printing on thin air like you told me down here. However, the way that it prints, you can actually print on thin air as long as you're going from one thing to the other. It's kind of like a bridge. A bridge doesn't just float there. It actually is on one side and the other. So as long as you're printing something like this, it'll do what's called bridging, and it's a very useful thing to put in your model, and when you're designing, thinking that you're going to print it. Remembering that you can bridge as long as you think about it. So if it's not too steep, and this part here doesn't go downward, like if it started down here and it curved down like a heart, that would not print without support material. But you can bridge, so that's a good thing. So if we had support material, this is what it would look like. And we were at 1 hour 22 minutes at 14 grams, I believe. Let's see. A filament. Yeah. So it changes by a gram, which is not much because this model doesn't use a lot of material, but it takes a little bit more time, and there's more time that you're not seeing. You have to take the time to get that all out, and it might not come off, and you might have to take sander to it, or you might have to cut at it. It's just annoying. And if we don't need it, why do we have it? Every printer is different. Every person who operates the printer is different. Even if they operate the same printer as you or me, we might get different results. So use support when you believe you need it, or after you've tried and you know you need it. I try never to use it as long as I am modeling it. If I'm not modeling something and I'm printing something that somebody else made, I might use it. So now we have build plate adhesion. I use a skirt, which is basically just lines that start to prime the nozzle. This will get the nozzle to have filament in it and ready to go. And if you don't have it, when you come down to the very bottom here on that very first layer, there might not be material coming out when it thinks it is. And if you want material coming out, put a skirt down. Other options are brim, which is a skirt, but it touches the model instead of outside. And, you know, that'll help with warping, but I usually don't have any issues with that. I use a glass blade and hairspray, and that works really, really well for me. Then there's the raft here, which is what a lot of people use when they start out, or when they're pros. I see all kinds of people use it. Stratasys 3D printers, those are really nice ones. They use rafts all the time, and I believe you can't change that by default. So you will always be using that material for your print. You can change the settings of it, of the raft, but when you use a raft, you're using that material as just a waste product. So skirt uses a lot less, and I find that I don't need anything more. Dual extrusion, mesh, special modes, experimental, those things are more advanced. We don't need that for this model. So in order to save this, I'm just going to plug in my SD card, and we're going to save this to the SD card and get it ready for print. So we can change the name here and then choose where we're saving it. I'm going to save it to the drive, and it'll take 34 cents and 14 grams filament. This is how many meters I believe it is, and then how long. So just click save, and it's saving it, and then we're done. All right, well, thank you for watching. Hope this wasn't too much of your time. If you like this video, there will be more to come, and I'm printing out a camera mount for my printer that I made so that you can watch this print. So subscribe if you want to see it, and I'll see you next time. Bye.